In this problem, we'll see how to identify and graph a hyperbola. Let's look at our helpful hint. The standard form of a hyperbola with the center at the origin and vertices -a0 and a0 has the equation x squared over a squared minus y squared over b squared equals 1. Here we have an equation of a hyperbola. We know it's a hyperbola because it's in the form x squared over a number minus y squared over a number equals 1. If we want to graph this hyperbola, we first need to find the vertices. And the helpful hint says that the vertices are at a0 and -a0. In this case, we know a squared is 10. And if we solve for a by the square root property, we have a is plus or minus the square root of 10. So our vertices, one of them is at square root of 10, comma 0. And the other is negative square root of 10, comma 0. So we have our vertices. Another thing about graphing a hyperbola is something called the fundamental rectangle. We need to find the corners of that rectangle. In order to do that, we also need to find b. We have our a, we need to find b. In this case, we know b squared is 9. And using the square root property, b is plus or minus the square root of 9, or plus or minus 3. Now the four corners of the fundamental rectangle we can find by taking square root of 10, comma, positive 3, or corners of the rectangle. One corner will be square root of 10, comma 3. Another will be square root of 10, comma negative 3. And then negative square root of 10, 3. And the fourth corner will be negative square root of 10, comma negative 3. Now we'll use the vertices and the corners of the rectangle to graph a hyperbola. So we found the vertices of our hyperbola, and we also found the four corners of the fundamental rectangle. So now we're going to graph our hyperbola. Our vertices are at square root of 10, 0, and negative square root of 10, 0. And the square root of 10 rounded to the nearest tenth is about 3.2. So one vertex is at about 3.2, comma 0, which is about there, and the other one is about negative 3.2. So we have our vertices, and we know the two branches of the hyperbola will come through those points, but right now we don't know how wide or how narrow to make those branches. So that's where the fundamental rectangle will help us. So we've got the four corners, square root of 10, comma 3, so that's about 3.2, comma 3. It's about here. And square root of 10, negative 3, so about 3.2, negative 3. It's the second corner. And this corner, about negative 3.23. And the fourth corner at about negative 3.2, negative 3. So I'm going to draw the rectangle with a dashed line. And then I will draw the called asymptotes through the opposite corners. And those will be kind of our guidelines when we go to draw the two branches of the hyperbola. So I know the hyperbola needs to go through this vertex, and this dashed line tells me I need to keep that within this area. So my hyperbola is going to look, there's one branch, and the other branch, same thing, needs to go through this vertex, but stay within the dashed lines. So there's the graph for our hyperbola. Now remember, the hint told us that if we have a hyperbola in this form, where the x squared term is first, we can find the number under the x squared term to be a squared, and that will help us find the vertices to be a0 and negative a0.